So some things to consider as you look at moving to a multi-axis or a 5-axis environment. One of the things that I've seen a lot of customers have to make the transition to is building machining processes that are stable. And when I say stable, I mean they don't need a lot of help from the operator. One of the downsides to vertical machining centers is they have a door on them. Now, obviously, you need a door to feed these things, but most often the door is used to get in and rescue the process, either chip control or point coolant or what have you. In 5-axis machining, we want to build a machining process that does not have to be rescued by the operator frequently. Another area where some companies struggle is they're so used to using a whole lot of fixture offsets to deal with where their tooling is. In 5-axis machining, and especially in contouring, we typically use the machine origin or the machine coordinate system to program. We don't use a lot of fixture offsets because it gets very hard to manipulate those, and it's actually counterproductive. You need a very good control system. There are a lot of products out there, lower cost products, where yes, they're a 5-axis, but when you really put them into 5-axis machining, the control system doesn't have enough horsepower to do some of the machining processes that we need to deploy. You want to tailor your software, control software options to your process. All of the major control manufacturers will have sheets and sheets of options that apply to 5-axis machining. And as you sit down with a vendor of machine tools, you're going to want to go through these software options because some of them can have a significant event or a significant impact on what you're doing. One of those is tool center point control. TCP is it's called by most folk. You can think of that as 5-axis cutter compensation. If you program vertical machining centers, you're very familiar with cutter radius compensation. TCP takes it to the next level. If we jump back in time in programming a 5-axis, we used to have to put into the CAM program the relationship of the center lines of the rotaries and the tool offsets so it could calculate all that into the NC code. Nowadays, the CNC controls have enough horsepower to where they can do this in real time in the same way that cutter compensation works on a machining center you might own now. So you will want to use TCP. It greatly improves the accuracy that's available out of these machine tools. Another thing that I've seen in the industry as companies that had 3 or 4-axis machines migrated to 5 is they very quickly ran into the situation with the CAM system that they're using, which might have done very, very well for vertical machining centers and 3-axis operations, is not capable of 5-axis. There is a significant difference in the user interface and the functionality of CAM systems when you make the move from 3 or 4-axis contouring to 5-axis. And you need to allow time to learn that CAM system prior to the machine showing up. The other area that I recommend, and this is a personal recommendation, when a company makes a transition to 5-axis or multi-axis machining, they should plan on spending a good portion of the budget on training for both the CAM system and the machine tool. There is a significant difference in what you need to know as you move to multi-axis machining. And the owners, the people that are making decisions, need to budget some money for training and allow for that learning curve to happen. And this is a little bit of promotion, but you're going to need some help. If you're running vertical machining centers or even horizontal machining centers, if you're contouring 3 or 4 axes and you make the move to 5-axis, there's a lot of things you're going to have to learn. Now, they're not difficult. It's just there's a lot of it. And you need to plan on the fact that you're going to need support from whoever you buy the machine tool from and whoever is the vendor of the CAM system, because you're going to need to learn some things to get the full utilization of the machine tool.
I'm going to go and introduce Michael Grant. He works for Applied CAx. He's our CAM application guru. Before that, he's been out there. He's a manufacturing manager, both for Orion Industries and then here locally in the Portland area, US Digital. So he has a lot of experience as far as evaluating different CAM systems, making sure to get projects done on time, and really just everything that goes into that. And then since then, he's gone ahead and came on with us to help our customers out and maximize their efficiency. So, Michael, I'm going to go ahead and hand it over to you. Are you on okay?
Yeah, thanks, Ian. And thanks, John. So, first off, as John had said, we do see people evaluating their machine tools and software once they get beyond that 3-axis vertical and horizontal machines. And so when they get to that 4- and 5-axis and beyond, they're really looking at evaluating what they have and looking at something that can more tightly integrate and control their machines and verify what they're doing, their process, and that it's the software is capable and complex enough to simplify what the experts or people who are programming need to do. So it's important to have software that can take something that's complex and really simplify it because it's powerful on the back end. And so we see that as a high need. And especially when you're going to be introducing advanced machining methods, TCP, and being able to control your process better, advanced tool paths, and as John said, just having a stable process instead of just a high speed process that requires your operator to be there and watching the process and speeding it up and slowing it down. So what we're able to do with our software is control the process and have the feed optimized based on the chip load and based on how much it's cutting, so it makes for a more stable process. The next thing we see is just being able to handle the solids and various information that comes from many different suppliers. It might be coming from any number of software packages, and just being able to import that and have a good quality solid to work from, and being able to do all your engineering in one package instead of transferring it between a design tool and a CAM package. So having that integrated engineering complete solution that you can do everything in one, your drawings, handling 3D PMI, which is your 3D part manufacturing information, might be dimensions or tolerances, surface finishes, and then being able to also do 2D drawings if needed, and your CAM, changing your solids for manufacturability, maybe designing in different stages for your in-process workpiece. So just having a total engineering solution rather than kind of piecing things together. And of course, being able to verify your process so that when you send it down, to the machine, up or down, depending on where you're located. Being able to verify your process in true GCode simulation is highly important when you get into multi-axis, so that maybe your complex cycles, your 3D tools, center point offsets, and just being able to see all of that in real time and actually looking at the code after posting it. So it's not looking at the internal code, rather the G-code, the exact code that would run on your machine. You can even take a code that's been output from another CAM package and run it through a real G-code simulator. So that's we found that to be a very important part of the process. It's definitely you don't want to have your spindle, your clearance is off, thinking your cutter's long enough, but once you tilt that the table, it's not as you don't have as much clearance as you thought you might have. So here we're looking at, as John said, an articulated table, and so we're able to, it's important to have a CAM solution that can simulate your different types of machines. So, again, it's just a closed loop engineering part process, being able to be integrated across all manufacturing, have a solution for all different types of machines, handling your parts solids, extracting high-quality surfaces from your solids for the different needs in manufacturing, doing your tool management, optimizing cutting methods so that you have a stable process, and again, the true NC simulation. And then when you've completed this process, it's important to be able to communicate this to the floor, so outputting your shop documentation that clearly shows what you will be doing on the machine so that the operator is more comfortable with what they're going to be seeing and knowing what to look for. We've even seen where customers are setting computers down at the machines and using viewer type software, that the NX offers is a viewer that you can do true GCode simulation without having a full license. So having the operator be able to watch the process exactly as it's going to happen on the machine so that they don't have any unexpected moves that they didn't know were coming. And then again, when you are tightly integrated with software and the solids, being able to replace that solid with a new customer revision, do analysis of what's changed, and being able to implement that revision without having to recreate your entire program. Having a software package that can handle a part replacement, give you the information you need to know what's changed and reuse all of your operations, not having to throw them away, just pointing them to the new solid, saying, this is what I'm going to cut now, updating that, and being able to quickly output that new revision to the floor, saving time and obviously money. What we've seen, as John said, talking about, you want really a vendor partnership. And so with your machine tool supplier and your software reseller or supplier, it's important to have that partnership, someone who's going to work alongside you. It's one thing to have a powerful software and a very capable machine, but not being able to use those tools and get your questions answered when needed and having the necessary training and communication really renders those useless. And so, that's what we like to see happen with customers and what we work tightly with our customers. And then like having a tight controller integration across many different controls, as John stated, the Mitsubishi, Fanuc, Heidenhain, Siemens, and obviously many others, and being able to simulate that with a full machine simulation and looking at the actual code that will run on that machine. So the common mistakes we see is just involving your vendors and partners maybe late in the game, last minute, because you really want to make sure you're going to have a complete solution and be able to get that machine running as quickly as possible instead of waiting for a post-processor or a simulation kit or even the necessary training to get the utilization of the machine tool and software. So involving the support parties early and just making sure that everything's in line and that the vendors that you're working with are going to be there for you and help you through the process and really help you get the most money out of your investments. And so, that's an important, definitely a common mistake. And just being able to get everything up and running is important. All right, and I appreciate everyone's time, and again, we're open for questions at the end if you have any questions, and thank you very much.